Hello and welcome to Quantum IAS. From this video onward, we are going to start our flash series. And in this series, we are going to cover topic by topic. So the first topic in this series is regarding the density of state, and it is written in the quantum mechanics module 2, module 1 of paper number 2. So density of state, we will study. This is the handout that you will be given. You can check the description of this video for this handout also. Let's begin our discussion. So first of all, what do you mean by density of state? So density of state is defined as number of different state at a particular energy level that a particle electron generally are allowed to occupy. And this is what we mean mathematically by density of state. समझते हैं क्या? Density basically means any quantity over the dimension that we all know. And state in quantum mechanics is what we known as eigen functions, right? The solution of the eigen value problem that we are getting. Also, it is also known as modes also, right? So in some of books or in some of the material, you will find eigenfunction, some of you will find states, some of there you will find modes. Now, let us define what is density of state. So let's say this is one particular energy level, this is one particular energy level, right? Number of different state that are occupying at each energy level, right? Or let's say this is the energy state that we are focusing on. तो इस एनर्जी लेवल पे कितने सारे स्टेट मोड या आइगन फंक्शन प्रेजेंट होंगे, दैट इज बेसिकली द डेंसिटी ऑफ स्टेट, राइट? मैथमेटिकली इट इज जीई, जीई से डेंसिटी ऑफ स्टेट डिनोट करेंगे. dn is the number of particle, right? dn is the number of particle whose energy is lying between e plus de. Now one thing you should note here, that we have written de here, right? That means we are considering density of state to be continuous. This is what we need to assume. So in the following derivations also, we will take the value of volume, area, or L in such a way that the density should be continuous, right? And this is the way we can get number of particle, right? ये है क्या? G D क्या है? Number of particle between E to E plus DE. And जब उसको integrate करेंगे 0 से E, we will find the number of particle. So this is about the introduction. So we will see also क्या क्या questions आए हैं previous UPSC में और उनको handle कैसे करना है. So first of all, this is the definition you should know. Next one is the graph, right? हम लोग we will also see these things, right? How the variation of DE versus E in the following cases, right? 3D, that is our bulk material, right? 2D, also known as quantum, well, quantum wire, and quantum dot. So these are basically different dimensions possible, and this is how energy is related to the density of state. Here you can see that when energy is increasing, density of state is also increasing, right? Here you can see that at a particular given energy level, density of state is constant, right? Here density of state is decreasing as we are increasing the energy, right? Here it is the delta function. We will see these things one by one. So this is the graph, standard graph that you can use in your answers, right? Now these are certain formula. We will also derive these formula. Okay, so 0 dimension, This is the formula. One dimension, this is the density of state. You can see it is a delta function. From the graph, you can also see here e to the power minus 1 by 2. This is very important, right? Here e to the power 0, you can see it is not doesn't depend upon the energy. And here GE proportional to e power half. This is very important, right? Let me tell you one thing. We have different type of particles, right? So based upon which type of particle we are using, if you are using bosons or fermions, right? You have already studied about these things. So density of state might change because let's say for electron, we know that at a particular given energy state, electron can have two different states, right? Pauli exclusion principle. We know these things. So we will use these things. So we will derive these now. But before deriving, let us understand something, that what do you mean by quantum well? Why 2D wala problem, right? So this is, I have given the definition of quantum well. This is the definition of quantum 1D. This is the definition of quantum dot, right? These are the standard definitions. What I'm trying to say that you're going to write your mains or this year or coming year, you should be thorough with your definitions. Definition should be exact, right? And now after definition, we have certain important things to look upon, right? The density of state plays important role in kinetic theory of solid, right? You will see that basically it is used to investigate various physical property of the matter, right? I hope ये जो handout तुम लोग को मिलेगा, you are going to read these things, right? I'm just focusing on different things. Density of state is also related to the dispersion relation, right? Higher the density of state means higher states are available for the relations, right? It also shows the distribution of electrons changes as dimension is reduced, right? For quantum wire, we have seen already from the graph also, right? It is 0 for those photon energies, right? Semiconductor with quantum dots are used as cascade laser, IR photodetector. Quantum dot is also useful in quantum computing scheme, optoelectronic devices, injection laser, fast DNA testing, 3D imaging inside living organism, right? These things you can add. Even for diode and laser, right? Quantum well, because UPSC favorite is quantum well, so it is also used in diode, right? Laser, right? Red lasers for DVDs. So these are certain functions or application of quantum well also. Now moving forward, density of considered to be homogeneous and continuous. We have already said that the energy should be continuous when you are defining the density, right? It should not be discrete. Also intertwine the Fermi level, right? इसके just बाद अगर syllabus पढ़ोगे, there is free electrochemical theory that you read about Fermi level, right? You can also find out the Fermi level, right? Application density of state, determine the carrier concentration in materials, including in doped semiconductor, right? Also in nanotechnology, right? So I hope you're going to read these value added points and you can use these points in your conclusion as well, right? So we have seen, if you're going to write answer, this is basically answer writing focused discussion. So you have basically intro to write, diagrams to make or graph, right? You have main body part to write, let's say derivation that we are going to, and conclusion, right? So intro we have done, diagrams we have seen also, conclusion we have seen. Now for body part, the derivation is the main in these types of question, we will see that. But before that also, let's have a look before the question, previous year questions that will serve as our guideline. Okay, so calculate the density of state of electron freely moving inside a metal with the help of quantum mechanical Schrodinger equation of free particle in a box, right? Now understand here, electron is given here, right? Electron is important. Simple particle नहीं है, electron है, that is fermions है, and it will obey Pauli exclusion principle, right? देखो एक यहाँ पे एक मिसकंसेप्शन होता है दैट डेंसिटी ऑफ स्टेट का फॉर्मूला लोग याद करते हैं, वहां पर डिस्टिंग नहीं कर पाते हैं कि वेदर दे आर यूजिंग फॉर फर्मियंस और अ सिंपल पार्टिकल, ठीक है, दैट वी विल डिस्टिंग्विश हियर आल्सो. नाउ show that free electron density of 3D varies at these same that we have seen in the graph, right? We will also try to prove. So again it is of 2016, 18, again in 19 they have asked, right, to find out this relation, right? You can easily find it out. We will see how we can do it. Again, show that G by D by dP, right? Gp is proportional to P square for a non-relativistic particle. We will see the relativistic case also. That's not a worry about that, right? So let's start our discussion. So let's start with our quantum dots have huge applications, right? We have already seen in the our value added point. So let us write down some point about it. There is no derivation involved in this question. So we will write at quantum dots, there is no K space. We don't have any K space. I guess you know about the K space, right? E barabar h square upon 2m, h square k square upon 2m, right? K is basically the propagation vector, right? Related to the momentum. I guess you know these things. So no momentum, right? Basically, there is no free motion is possible. I hope you are taking down these notes, right? And all the available states exist only at discrete level. जितनी भी चीजें हैं, जितनी भी अवेलेबल स्टेट है, सारी की सारी क्या होगी, डिस्क्रीट लेवल पे एग्जिस्ट करेगी. नो कॉन्टिन्यूटी इज देयर, राइट? सो वी कैन से सिंपली दैट that the density of state GE is basically 2 delta E. 2 delta E. You can use that, right? So this is more than sufficient for 2D. Now let us turn 1D, one dimension, quantum mechanics. From here you need to understand things, right? Now let us assume, see, we are assuming these things, but it doesn't mean that it will be valid only for this case. It is valid for all one-dimensional problem. So let's say the eigenvalue of a particle in an infinite deep square well is given by, we know that En, or simply you can write E n square h cross square pi square upon 2 ml square, or in terms of K also we can write that it is h square K square upon 2. This we know, and this I expect you to knowing, right? किया होगा 1D potential, infinite potential, right? Where n is basically 1, 2, 3, and so on, whole number, and K is equals to n pi by n. So K can take the value of n pi upon L. Now understand one thing here. Simply focus on this thing, that we are writing E is equals to square over h cross square k square upon 2m, right? Is it a parabolic function? So let's draw it. If you understand the meaning of this thing, you will understand the whole motive of density of state. ये सब में एक ही चीज है, right? Now this is E and this is K. E versus K we have drawn here. Now let me tell you, this is K and let's say this is K plus dk, and this K corresponds to E and this K plus dk corresponds to E plus de, यही तो होगा, right? और इनके बीच में क्या होंगे? different states होंगे, right? Now can we say that the number of state between K plus dk is equals to number of state between E plus de? जितने number of state, देखो हर एक E corresponds to a K, हर एक E के पास एक K है, K से रिप्रेजेंट होता है, every E corresponds to a K, right? So K plus dk से लेकर K के बीच में जितने भी स्टेट होंगे वही स्टेट क्या होंगे? E से लेकर E plus dk. So I'm writing one thing, just note it down, that is GE DE, यही तो नंबर है. अब हमने देखा है कि डेंसिटी ऑफ स्टेट इज व्हाट? DNE अपॉन DE. ये सीखा है हमने डेफिनेशन से कि डेंसिटी ऑफ स्टेट इज व्हाट? नंबर अपॉन एनर्जी वाला कॉन्सेप्ट. तो दिस नंबर इज सेम, तो GE इनटू DE इज इक्वल्स टू GK अपॉन DK. अब चलो एनर्जी क्या? K मोमेंटम, बात बराबर, GP इंटू DP. Similarly, G omega into D omega, right? All of them are representing what? Energy. K बोलो P बोलो बात बराबर है, E बोलो ओमेगा बोलो बात बराबर है एनर्जी के, right? So if you have understood this concept, then जो ये क्वेश्चन आया था इधर, you can easily find it out, right? Easily you can solve based upon our discussion. Now let's try to focus on this, that K is what? Integral multiple of pi by L. So अगर K इंटीग्रल वैल्यू ऑफ पाई बाई L है, मतलब K की कौन कौन सी वैल्यू हो सकती है? तो लेट्स टेक K की वैल्यू हो सकती है पाई बाई L, K की वैल्यू हो सकती है 2 पाई बाई L, K की वैल्यू हो सकती है 3 पाई बाई L, K की वैल्यू हो सकती है 4 पाई बाई L एंड सो ऑन, राइट? ये जो नंबर लाइन है वी कॉल इट एज K स्पेस. कैसे हम लोग ये बनाते हैं और बोलते हैं इसको एक्स वाई स्पेस, या सिंपल ये बनाया तो बोल दिया एक्स स्पेस या एक्स एक्सिस, राइट? सिमिलरली वही चीज है. अब यहां अगर देखा जाए so can we say that here one state, एक एक स्टेट सब पे है, राइट? देखो ये बताया जा रहा है that k की वैल्यू क्या हो सकती है? n पाई बाई l. k की वैल्यू क्या हो सकती है? n पाई बाई l. नाउ हम अभी क्या कंसीडर करना है? अगर इफ यू वांट टू मेक इट कॉन्टिन्यूअस, l इज वेरी बिग. अगर l बहुत बड़ा हो जाएगा तो जो ये गैप्स है, these gaps will come closer. गैप कितना है? पाई बाई एल का. गैप कितना है? पाई बाई एल का. गैप कितना है? पाई बाई एल का. तो हर एक आदमी, जैसे मान लो ये इंसान है, तो हर एक इंसान कितनी दूरी पर खड़ा है? पाई बाई एल, पाई बाई एल, पाई बाई एल, पाई बाई एल. So if L is big, then density of state become continuous. It become continuous. तो ये मतलब है. अब अभी के बाद जितने भी डेरिवेशन करेंगे उसमें L को हम लोग बिग लेकर ही चलेंगे, so that density of state is continuous, right? अब देखो डेंसिटी सिंपली कैसे निकालते हैं हम लोग? जो क्वांटिटी है अपॉन डायमेंशन, राइट? सिंपल रूल बता रहा हूं, एग्जाम में डू नॉट डू लाइक दैट, बट समझने के लिए बहुत सही है. पाई बाई एल, पाई बाई एल पे एक मिल रहा है, सो पाई बाई एल दूरी पर हमें मिल रहा है एक स्टेट, राइट? सिंपल यूनिटरी मेथड. pi by L distance, we are getting one state. So at one distance, we will be getting pi upon pi by L, right? So if the distance become dk, if the distance become dk means k space छोटा कर रहे हैं हम लोग, right? So if we can find the dk, we can find the density, right? In real life, how you define density? Density is dm by dv, right? Volume density define करते हो, या अगर lambda define करते थे, so dm by dl, right? ये तो था कि छोटे स्पेस में डिफाइन करना में. सो डीके स्पेस में वहां पर लेंथ था, यहाँ पर क्या है, के है. वहां पर एक्स था, यहाँ पर के है, राइट? तो डीके स्पेस में व्हाट विल बी डीएन? ये सारे क्या है? ये तो नंबर ऑफ स्टेट ही तो है. पाई बाई एल में कितने स्टेट है? एक. एक अगर के की वैल्यू 1 हो जाए तो कितने स्टेट होंगे? इतने, राइट? सो अगर डीके हो जाए तो कितना स्टेट होगा? इट विल बी डीके अपॉन पाई बाई. दिस इज वेरी इंपॉर्टेंट टू अंडरस्टैंड. अगर ये समझ में आ गया तो फिर काम अपना हो गया, राइट? दैट सिंपल यूनिटरी मेथड है, राइट? पाई बाई एल में एक है तो एक में 1 पर पाई बाई एल होगा, तो डीके में कितना होगा? डीके अपॉन पाई बाई एल. ये है नंबर ऑफ स्टेट. अब E is equals to h square k square upon 2m. That means k will be root under 2me upon h square. तो निकाल देते हैं. डीके चाहिए हमें. What will be dk by de? Differentiate करेंगे एनर्जी के रिस्पेक्ट में. What we will get here? So we will get root 2m by h square same रहेगा. E to the power half. पहले हाफ देगा and then ये माइनस हाफ हो जाएगा, right? This is what we get upon dk upon de. इसमें पुट करो. What we will get? So dn that is equals to dk by pi by L. We get under m upon 2h cross half e to the power minus half, right? And dk will be ये de इधर चला जाएगा, so into de upon pi by L upon pi by L, right? So dn by de देखो कितना आएगा. So dn by de multiplying. So L चला गया ऊपर, हाफ आ गया नीचे, right? So it will be L under m upon 2h cross pi square e to the power minus half. And it is what जो हमें निकालना था d. Take this calculation once. Okay, so this is density of state in one dimension. So we have seen the graph also. We can make graph here also, right? So if this is GE and if this is E, the graph will be something like this, right? That means GE, density of state, decreases as energy increases. Density of state decreases as energy increases, right? So we have done the introduction part, we have done the graph part or the figure diagram part, we have done the conclusion part, and we have done the main body part, that is derivation पूछा जाता है, and based on this question. So in 1D you will find like this, right? Now let's move to the 2D. Same method, exact same method we have to do for the 2D also, right? For 3D we will spend some time, because basically metals क्या होते हैं 3D में? Basically maximum structure that we are using for the electron itself, that is in 3D. Chalo, so again here eigenvalue problem वही लेंगे, well 2-dimensional well ले लेंगे, तो एनर्जी कितनी आएगी? अगेन h square by pi square upon 2m L square n square plus n2 square, right? I hope मैं ये मानकर चल रहा हूँ कि तुम्हें ये फॉर्मूला आता है, right? You have studied the particle in a box, सारे वो जो इसके पहले वाले चीजें हैं तुमने पढ़ रखी है. सो अगेन व्हाट विल अज्यूम, एच स्क्वायर बाई 2m की एक्स स्क्वायर प्लस के वाई स्क्वायर, और इसको भी हम क्या मान सकते हैं, के एक्स स्क्वायर और के वाई स्क्वायर को अगेन के स्क्वायर. ठीक. सो अगेन दिस रिलेशन विल बिकम exactly same as previous, but here kx is what, n1 pi by l, and ky is what, n2 pi by l, and kx square and ky square is equals to k square. ये हम लोग ले रहे हैं, right? Now let's draw here, and energy is again h square k square by 2m. This is what we are taking as energy, right? Now draw. 1D में एक डायमेंशन ड्रॉ किया था, 2D में हम लोग 2 डायमेंशन ड्रॉ करेंगे. Here we are putting ky और इधर क्या पुट करेंगे, kx. अब देखो kx और ky में क्या है, डिफरेंट सेट्स ऑफ वैल्यू ले सकता था, राइट? जैसे पाई बाई एल, 2 पाई बाई एल, 3 पाई बाई एल, 4 पाई बाई एल एंड सो ऑन. kx की यही वैल्यू ले सकता है वो. अगेन ky में भी क्या ले सकता है, पाई बाई एल, 2 पाई बाई एल, 3 पाई बाई एल, 4 पाई बाई एल, राइट? सो ये पॉसिबल वैल्यूज है, राइट? अगर हम ये 4 वैल्यूज को देखें, राइट, सो kx में क्या वैल्यू पॉसिबल है, पाई बाई एल, 2 पाई बाई एल, 3 पाई बाई एल, 4 पाई बाई एल पे. These dots are representing our values that are possible, right? We have taken L to be small abhi tak. If L is big one, right? If L is big, then these point will be closer to each other. अगर L बड़ा होगा तो ये पॉइंट क्या होंगे, क्लोजर होगा एक दूसरे के, राइट? नाउ एक चीज देखते हैं हम लोग. लेट्स टेक वन स्मॉल एरिया. यही तो गैप है. उसमें जो गैप था लीनियर में क्या था, पाई बाई एल पाई बाई एल पाई बाई एल का. इसमें गैप कितने का होगा, पाई बाई एल स्क्वायर का. सो पाई बाई एल स्क्वायर पर हम बोलेंगे कि एक स्टेट है. अब सुनना कैसे, पाई बाई एल स्क्वायर तो एरिया तो समझ में आ रही होगी कि हर एक जो बॉक्स है ये कितना है, पाई बाई एल है, और ये भी कितना है, पाई बाई एल. हम बोलेंगे पाई बाई एल स्क्वायर पे एक ही स्टेट है. क्यों एक ही स्टेट है, यहाँ तो मैं 4 डॉट दिख रहे होंगे, राइट? बट ईच स्टेट इज शेयर बाई एडजेसेंट 4 ब्लॉक्स. देखो ये क्या है, एडजेसेंट 4 ब्लॉक में ये है, राइट? सो इफेक्टिव कितना होगा, स्टेट 1. तो यहाँ भी वही है कि पाई बाई एल स्क्वायर में कितना स्टेट है, एक. तो एक में कितना होगा, 1 अपॉन पाई बाई एल स्क्वायर, राइट? ठीक है. तो जो छोटा सा एरिया हो उसमें कितना होगा, राइट? अब एक चीज देखना अच्छे से, वी हैव टेकन डीके. व्हाई? दिस इज द एलिमेंटल लेंथ, दिस इज द डीके इज एलिमेंटल लेंथ. अगर 1D में एलिमेंटल लेंथ पे हम देख रहे हैं, ऑब्वियसली बात है डेंसिटी किस पे निकालेंगे, यहाँ देखो डीएम बाई डीएल था, रो क्या था, डीएम बाई डीवी, सिग्मा क्या पढ़ा तुमने, डीएम बाई डीए, राइट? तो 2D में एलिमेंटल लेंथ लेंगे या एलिमेंटल एरिया, एलिमेंटल एरिया लेंगे, राइट? सो के क्या होगा, कोई भी एक वेक्टर होगा, ये दिस वेक्टर विल बी अ के, राइट? और ये डीके, दिस डीके. ऐसे ही तो एलिमेंटल लेते हैं. अगर हमें एलिमेंट लेना है तो ऐसे ही तो लेंगे, राइट? वी हैव ऑलरेडी डिस्कस व्हाई के इज पॉजिटिव, हम लोग सिर्फ कोऑर्डिनेट क्यों लेंगे. तो व्हाट इज द एरिया ऑफ दिस लेंथ, एलिमेंटल लेंथ का एरिया कितना होगा, तो रेडियस इज आर. so this dA is basically 2 pi k into dk. I hope you know these basic stuffs, right? क्योंकि ये कितना होगा, it will be by 4. By 4 ये quarter है, right? 2 pi k dk is the elemental area of the annular ring. तो dA क्या है? 2 pi k dk upon 4. So इतने में कितना स्टेट है? That is basically our dn. So dn simply means, what will be our dn? dn simply means कि 2 pi k dk upon 4 में कितना होगा, right? So we can do that. Put the value here. So let's find the value of k and dk. So simply dA by pi by L square. ये तो निकालना है हमें. As simple as that. This is the relative state. इसके हिसाब से. So put the value of dk. So can we write that dE by dk, E जहां पर है हमारा h square k square by 2m, अगर डिफरेंशिएट करें तो क्या आएगा? d by dk 2h cross h cross by 2m and k become 2k, right? So यहाँ से लिख सकते हैं हम लोग 2 pi k dk, इधर पाई से मल्टीप्लाई, इधर पाई से मल्टीप्लाई कर देंगे, तो विल बिकम 2m pi h क्रॉस स्क्वायर de. पुट कर दो. व्हेन यू विल पुट dn, हमें 2 pi k dk नहीं चाहिए, हमें 2 pi k dk by 4 चाहिए. So we put 2 pi k dk by 4. So become 2 pi de upon h cross into 1 by 4 upon pi by L square. तो ये तो 2 हो गया. Right? Okay. So it will simply become m. ये L ऊपर चला जाएगा तो L square upon 2h square pi de. So dn by de, this is what we need to find out. Ge is equals to ml square to h square. This is basically independent of energy that we have already discussed in the two-dimensional quantum well, right? It is using diode, laser, all these things. So it is independent of the energy that you need to prove here. Okay, I guess done. Now let's come to the 3D. Let's talk about 3D. Same thing you are going to do in 3D also. If you have understood the concept in 1D, 2D, 3D, you can easily apply in 3D. In 3D, what will be the energy? Particle in a box. अच्छा, we are taking L square का आइडिया ले रहे हैं, या फिर यहाँ पर वॉल्यूम लेंगे, वो क्यूब का वॉल्यूम लेंगे, बट इट डजंट मीन दैट इट इज वैलिड फॉर क्यूब ओनली. इट इज वैलिड फॉर एनी टाइप ऑफ एरिया, any type of area, any type of volume. Formula will be valid because we are treating it as continuous, right? So for our mathematical ease, we are taking cuboidal लेंगे यहाँ पर, but ऐसे we can use. So n1 square plus n2 square plus n3 square. Again इसको kx, ky, kz मान ले, so h square upon 2m kx square ky square plus kz square, right? Again इसको क्या मान लेंगे हम? k square. तो फिर से फॉर्मूला वही आ गया हमारा, E is equals to h square by 2m k square, right? अगेन फिर यहाँ से हम k निकालेंगे, अगर हम dk निकाले तो वही फिर फॉर्मूला आ जाएगा हमारा, वही पुराना वाला 2m by h square 1 upon root 2e de, right? अब देखो, if we are going to draw the k space here, समझो अच्छे से, कुछ भी चेंज नहीं हो रहा है। लेट्स से x y and z, सॉरी kx ky and kz, k स्पेस में काम कर रहे हैं हम लोग, राइट। तो k यहाँ पर क्या होगा, पाई बाई एल, 2 पाई एल, 3 पाई बाई एल, 4 पाई एल, 5 पाई बाई एल, सेम। इधर ही पाई बाई एल, 2 पाई एल, यहाँ पे भी सेम, राइट। और यहाँ पे जो एरिया आएगा, लेट से अगर ये एरिया हम मर्ज करेंगे, सो इट विल बी एन ऑक्टेंट, 1/8 पार्ट ऑफ स्फेयर। जैसे इससे पहले क्या आया था, 1/4 पार्ट ऑफ सर्कल। 3 डायमेंशन में क्या आएगा, 1/8 पार्ट ऑफ द स्फेयर। तो यहाँ पर हम लोग डीवी क्या लिखेंगे पता है, 4 पाई k² इंटू डी के, ये तो लिखते हैं हम लोग पूरे एलिमेंटल वॉल्यूम स्फेरिकल में क्या लिखते हैं, 4 पाई r² इंटू डी आर। बट उसका कितना पार्ट लेना है हमें, 8 पार्ट, सो अपॉन 8 लिखेंगे, राइट। अगेन यहाँ पर भी क्या है, पाई बाई एल, पाई बाई एल। सो अब पाई बाई एल क्यू में कितना स्टेट था, एक स्टेट। तो एक डायमेंशन में कितना स्टेट आएगा, 1/पाई बाई एल क्यू, राइट। सो डीवी में कितना आएगा, यही तो डीएन निकालना है हमें, तो डीएन विल बी व्हाट, डीवी अपॉन पाई बाई एल क्यूब। डीवी विल बी व्हाट, पाई बाई एल क्यूब। अब पुट करते हैं इसकी वैल्यू कितनी आएगी, तो डीवी मल्टीप्लाई करते हैं हम लोग, तो डीवी इज व्हाट, 1/8 4 पाई k²। डी के की वैल्यू पता है हमें, ई की वैल्यू भी पता है। सो सिंपली ये तो 2 हो गया, तो पाई/2 k² को एनर्जी के टर्म में लिख सकते हैं हम लोग, दैट इज 2me/h²। एंड डी के वी हैव कैलकुलेटेड, √2me, √2m/h², 1/√2e de। Okay, this is dv that we are getting. You can simplify it here. So if you will simplify √e say, it become √e, 2 it will come inside, and when pi 2 से 2 खत्म, here also 2 finish, 2 √2 will remain. So pi by √2 will be there, m/h² power 3/2. You can see here e half will be there, and into de. This is the dv. So what is ge? Ge is basically dn by de, right? And what is dn? dv by pi by l cube upon de. So इसको नीचे रखेंगे, de will cancel out, so you can pi by √2 m/h², 3/2 e half upon pi by l का cube, pi by l का cube. So we will have ge is equals to 1/√2 pi² m/h², 3/2, right? This become l cube. L cube we can write volume also, e², right? Simply l cube is volume. You can write simply volume also, right? Also sometimes we write density of state as a volume, so density of state per volume also we write, so e to the power half. This is very important, right? Now for fermions, example electron. So we know that for this it obey Pauli exclusion principle. So what we need to do, we just need to multiply it by 2. If you multiply it by 2, you will simply get GE root 2 upon pi square m upon h3 to LQ. Right? What we have done, we have just multiplied it by 2 times. Why? Because according to the Pauli exclusion principle, right, each state will be occupied by 2 electrons. Each state 2 electrons. I'm adding that each state 2 electrons. तो समझो कि कई बार क्या होता है, we see this type of formula, कई बार we see this type of formula, right? So एक वन स्टेट बोसोन्स के लिए तो ये यूज करेंगे, फर्मियंस के लिए तो ये यूज करेंगे. सो क्लियरली क्वेश्चन में देखेंगे कि whether it is written only particle or electron. Electron specifically है, so we will write this formula, right? Now one small thing, E is equals to P square by 2m, right? And we know that GP dP is GE dP. So what will be GP here? So GP here will be GE. We have already calculated. That is DE by DP. D by DP यहाँ से निकाल सकते हो simply, right? And if you put it, so GP will become V upon pi square H cube P square, where V is the volume. V is the volume that we have taken, right? Now one extra bonus, although it is not required, but again, for bonus, let's take the relativistic case. So relativistic case, we need to understand the energy is given by E square, that is equals to P square C square plus M square C4, right? And if we differentiate it, it becomes E dE 2E dE upon 2 C square P dP. 2 will cancel out and we have this relation, right? And using this relation, you can find out the GE. You can simply find out GE, right? How you can find out GE? So GE, you know, V upon pi square H cube C cube E upon E square minus M square C4, right? When energy is greater than mu C square. And there will be no state occupying if energy is less than the rest mass energy. Mu, sometimes it is written as reduced mass. We have taken MC square, right? Sometimes instead of M, we take mu, reduced mass. Sometimes we take effective mass, right? The concept will remain same at different places, at different situation. These things change out, right? हमने क्या किया यहाँ पर, हमने बस P की वैल्यू को चेंज कर दिया है. P स्क्वायर यहाँ से क्या निकाल लोगे, P की वैल्यू आ जाएगी, P की वैल्यू क्या आ जाएगी, E square minus M square C4 upon C square, right? वही हमने यहाँ किया. So you will put it the value, you will find the relativistic case. कुछ नहीं करना है, बस E की वैल्यू को ये यूज करना है, right? And also if E is much greater than MC square, right? That means the kinetic energy is much greater than the rest mass energy, or the total energy is greater than the MC square. So we can neglect this thing, right? And it simply become GE equals to V upon pi square H cube C cube E square, right? So again, these derivations are helpful. Again, the bonus relativistic case they have not asked, they have asked only for the non-relativistic case, right? Do remember these formations that we have studied, GP into DP barabar GE into DE barabar GK into DK barabar G omega into D omega. That is, number of state will be same. Every E corresponds to K, every K corresponds to P, every P corresponds to omega, right? This is what you done. Now, there is a small request from all of you guys. If you want these type of video, you need to do something from your side also, right? What you need to do, you need to complete your homework. If you will complete your homework, I will be posting these videos along with these handout description में मिल जाएगा, right? It will be available in the description. What is the homework? Comment the solution of questions given in the handout, right? So every handout will contain 3, 4, 2, 3, whatever the type of question. So for example, here we are having 4 questions, right? So try to attempt all 4 questions and post your solution in the comment. And also we request all of you to give a peer-to-peer review, right? Okay. Thank you for watching this video.